learned solar cell and how it generates power, electrical characteristic of a solar cell, maximum power point, solar panel, solar inverter, and grid-tied solar system. So if we wish to install large number of solar cells, solar panels on roof or open space in our home, several things to be considered. That is how many panels we can install on the roof considering the panel size and the row spacing. What could be the maximum power obtainable? How much DC and AC power we can generate over a year? How much will it cost? How can we sell the power to the grid? How much money we can save? And finally, is it financially a viable project? If a solar panel tracks the sun daily, that is, it is rotated in accordance with the sun's position, and another kind of tracking is needed. That is called seasonal tracking. In the winter time and the summer time, sun position varies, so the tilt angle should be changed. Due to this tracking, we can utilize 100% available energy. But for a fixed tilt angle, that is, the panels are all south faced and tilt at some certain fixed angle, then around 70% of the available energy can utilize. So actually the tracking cost money, so most of the cases we use non-tracking photovoltaic system. That is, we are getting 70% of the available energy. So what should be the optimum tilt angle for Vancouver? During the summer solstice, the sun makes an angle 64 degrees from the horizon, and in winter solstice, the sun subtends an angle 17 degrees. So during winter time, our panel should be 73 degrees to get the maximum power. And during winter time, summertime, it should be 26 degrees. So if we wish to use a fixed angle, for instance, around 30 degrees should be the optimum. Now another important consideration is the shading. We don't want our panel to be shaded by another panel under any circumstances. We have to consider the worst case scenario, that is in winter time. For instance, this is the first row of panel and sun is shining, and the shade from the first row of panel is shading part of the second row of panels. Then this part is not utilized, that is the shaded part, the power is unutilizable. So to get the maximum available power, the separation should be sufficient enough. In case of Vancouver, it is 7.4 meter. But in other regions, for instance, the places close to equator, this panel separation will be very, very short. How much energy we can get from a panel, that depends on seasons. For instance, during summertime, in June 21st, the solar intensity is also very high and we get a long daytime sunshine. And during winter time, that is December 21st, the solar intensity also goes down and the sunshine hour also is reduced significantly. So how much power we can get all over the year in average? First, we need to find out the DC maximum power from a panel or number of panels, and then the tilt angle, and then the sunshine hours. So let us consider that we are using 20 panels and the total DC maximum power is 390 multiplied by 20, that is 7.8 kilowatt. And we also considered tilt angle to be 30 degrees for Vancouver. So there are many cloudy days and sunny days. and how much AC power we can get. So we can use online calculator called PV watts to find out the total AC power output from our panels. So online calculator is developed by NREL. If you Google search PV watts, then you'll find that. So to get started, we have to type the region here and then press go button. Then we have to fill up some small places, that is DC system size. In our case, it is 7.8 kilowatt, and we are using fixed 30-degree, and we can consider 10% power loss. And our panels are in the south direction, south faced. So you can see that in all over the year, we can get maximum 8.9953 kilowatt hour. So this is the maximum energy we can get from our 20 panel solar system. So it also tells that the average daily sunshine hours, that is 3.92 kilowatt hour per meter square per day. So if we take a look at the map of BC, British Columbia, then we can see that I am considering the Vancouver, but in other places, for instance, Kelowna is at a higher latitude, but still we can get higher sunshine period per day. And if we compare this data with the southern California, that is 7.5 kilowatt hour per meter square per day. That is almost double to that of what I find in Vancouver. So California is financially more viable than Vancouver. So our system consists of 20 panels. Tilt angle is 30 degrees. So we already found that the maximum available AC power is 8953 kilowatt hour. So monthly we can get 746 kilowatt hour. So usually the household demand is 1000 kilowatt hour. So considering the BC Hydro rate, BC Hydro is the local utility provider, and their rate is $0.124 per kilowatt hour. So annual savings will be $1,100. So how much does a 7.8 kilowatt photovoltaic system cost? We have to consider cost of the panels, that is 20 panels, cost of the inverter, cost of installation, and balance of system, that is wiring, switches, junction boxes, and metering. So if we take a look at the trends in the photovoltaic cost, it goes down from 2007 and 2008. It was pretty high, and it is going down and down year over year. And in year 2021, around USD $1.2 per watt in the international market. So installation cost of a photovoltaic system in BC over 50 kilowatt is $2.52 per watt. So this information you can find in this place. So if we consider the pie chart, that is panel cost is 44%, inverter 17%, and installation and balance of system 39%. So we can find that the cost of 7.8 kilowatt photovoltaic system will cost $19,656. So simple energy economics, that is the payback period, system cost per annual savings, that is 17.8 years. Usually the lifetime of a photovoltaic system is 25 years. But the Energy economics is not so simple. Initial cost reduction due to tax credit, rebates from government, other renewable energy incentives, and there are some addition to the cost as well, maintenance and repair, cleaning the panels, snow and dust, extended warranty of the inverter. So all these things should be considered. In California, the payback period is usually 8 to 10 years. So for a photovoltaic system for a home in BC, we can use 20 panels, a inverter, we can use also a battery bank. So if we wish to buy individual things from local market, so how much it may cost? So I found out that LG panels, 20 panel will cost nearly $9,000. Inverter from local market, that is $2,650, and battery cost nearly $5,300, and other expenses are $6,000. So total it could be $23,000. And this 24.5 kilowatt hour system can give enough sufficient power for our kitchen, lighting, and washer and dryer. And this is enough for a small home.